All right. So we're gonna do day two of the chain rule product rule. Now, I make them specific. I name it specifically that because whenever you walk up to a term and you take the derivative of its term, every term has its own derivative. Every time you do that, and it involves a chain and a product, right? So the term might be a multiplication. So here's an example. This is what it's going to be. Why did that happen? Okay. So f(x) is going to be x squared times the square root. I'm going to make that pen smaller here in a second. Okay. What did you do to the pen? All right, let's see. Oh, that's okay. So that is when we walk up to this term. It's a one-term expression. It has a product in it. Sorry, it's so fat though. Has a product, and one of the factors requires the chain rule. So just to reiterate for those that weren't here, chain rule. This is going to be my little thinking box over here. Okay, chain rule is not required if I do the square root of x. It's the parent function. The only thing inside the function is x. However, as soon as I put anything other than x, then the chain rule is required, right? So that's really when and when not to use the chain rule. Okay, so now let's go and analyze this. Now, okay, so the reason I want you to focus and be specific about, I'm taking the derivative of a chain rule product rule, because there's an inherent GCF that will always happen. Always. So you're going to always be required to take it out. Now, I do warn you that it will take a bit of algebra skills. Right? So we're going to have to remember some of that. So don't confuse algebra with calculus. We can work on those and we can deal with that. And I'll try and explain it in here. But yes, separate what you're learning now and what's, from before. So let's go ahead and start deriving this and see what I'm talking about. So from yesterday, so we're saying, let's get rid of this over here so it's not in the way. All right, I am going to delete that. All right. So now, so f prime is going to be, now it's a product, right? So derive the first, leave the second, add to that, leave the first, derive the second, or whatever you do, if you've switched it around. So let's derive the first, which is 2x. We're going to leave the second. All right, and I'm going to need it as a rational exponent, a fractional exponent, irrational. So here in a second anyway. So I'm just going to convert this. I'm doing nothing other than just rewriting it. So I've just rewritten the second term, but I haven't derived it. So I did derivative of the first, leave the second, plus now I'm going to leave the first and do the derivative of the second. Now, the derivative of the second requires the chain rule, because it isn't just square root x. So to reiterate, the chain rule is you derive the outside, leaving the inside alone, times the derivative of the inside. So let's go ahead and do that. So, and I'll make sure you're seeing it as we're doing it. So I'm going to let's just put it in big, let's just change the color of this so we can see what we're doing. So the derivative of this term, is going to be the derivative of the outside with the inside left alone. So that means here, I'm actually looking at it right here. I don't know if you can't see that when I do that. So I'm looking at that term for an idea, right? So I'm going to pull the 1/2 power down, because that's what you do. It's a power rule. So you pull the 1/2 down, then you leave the inside alone. So 9 minus x squared. Then you reduce the power by 1. right? So we're just doing the power rule. Bring the power out, reducing by 1. So 1/2 minus 1 is a negative 1/2. Then I'm going to multiply it by the derivative of the inside. The derivative, so I'm basically looking at this right here. I want to know, what is the derivative of that? Well, we all know the derivative of 9 minus x squared is negative 2x. 9 minus x squared is negative 2x. So let's just put that on behind it. What's going on? I'm hitting the key button there. Okay. Negative 2x. I made the pen too thin now. Okay, so let's just go over that again to make sure we got it, and you can rewind as many times as you need. But look what we've done. We've done the power rule. So we brought the power down. Here it is. There's the 1/2. We brought it out in front. We left the inside alone. Look, I have done nothing to that. 9 minus x squared stayed 9 minus x squared. Then I reduced the power by 1. Then I multiplied by the derivative of the inside, negative 2x. So then, okay, so let's check the derivative of the whole thing. We're doing product rule. So I did derivative of the first, second, plus leave the first, derivative of the second. The derivative of the second required chain rule. And that was bring power down, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside. So that's it. And then we've done the calculus. Now we have to do the inherent cleanup. Because by the process of chain rule product, you making 2 terms where one of them stays the same and one of them reduces a power. Because of that, you will always have a GCF. So let's go find our GCF right now. So maybe we can clean it up just a little bit so that you can see the GCF a little bit better. So let's clean it up. So this is easy. 2x times 9 minus x squared to the power of 1/2. Now this needs a little bit of cleanup. So let's see. I've got 1/2 times a negative 2x. And then I've got that times x squared. So I'm going to do it in one step. So I got x squared times x, which is x cubed. And I got 1/2 of negative 2. So that means I've got negative x cubed times 9 minus x squared to the negative 1/2 power. Can't combine these x squareds and that x cubed. One's inside the function, one's outside. You can't rip that band-aid off, right? So that's kind of where we are right now. I could move the power down, but I don't want to do that yet, and you'll see why. So here comes the algebra lesson, so a free algebra lesson. So when you factor out, you want to take, okay, let me ask you a simple one, and a rhetorical, you don't have to say out loud. When I look at these 2 terms, when I look at that term, and that term, right, it's separated by a plus or minus. Would you think, just ask yourself, would I pull out the x or would I pull out the x cubed? And you say to yourself, well, I'd pull out the x because that's the greatest common. So it's the least power. So let's use that. So let's say least power. So let's pull everything out that's least power. And I'm going to speak it out loud for you. So I'm going to pull my equal sign over here so I've got a bit more room to write. Let's change that. Let's make it dark green, okay? So I'm going to pull out the least common of my x's. Well, x is the least common. And now I'm going to pull out the least common of a base raised to the power. Look, my base is 9 minus x squared. My base is 9 minus x squared. Those are common bases. One of them's to a power of 1/2. One of them's to the power of negative 1/2. So I ask myself the question, which number is furthest left on a number line? -1/2 or 1/2? And the obvious answer is -1/2. So I pulled that one out because that's the least power. So -7 is a smaller power than 2. You know, so it's further left. So that's what you're going to think about that. So you've got, all right. So now we've got my 9 minus my x squared to the power of -1/2. Now I'm going to pull that out of both terms. All right. So my current term is, well, let's simplify it. So what I did was I took, let's write it. I took 2x. Now, this is an unnecessary step. I will tell you that this is unnecessary, not required, but it might help show you what's happening. So 2x times 9 minus x squared to the 1/2. And what I did was I took out of that an x and a 9 minus x squared to the -1/2. That's what I did. So I'm showing what I pulled out, and then that'll show you the simplification. Then, what did we have to that? We had a minus, a plus, a minus there. So I have a negative x cubed. Do you see what I did there? I just combined that. X cubed, and your 9 minus x squared to the -1/2. And what I did was I factored an x 9 minus x squared to the -1/2 out of that. All right, now, it should be easy to see what we're doing now. So let's go ahead and move to the next step. I'll keep that there so you can see that. All right, so obviously the x and the 9 minus x squared to the -1/2 power is going to remain. Now, I divide 2x by x. So you're in your head, you're saying, okay, that's just 2. Then I'm dividing a base to the 1/2 power divided by a base to the -1/2 power. So properties of exponents. So I'll write it out. Once again, it's unnecessary. So that means I've got a 9 minus x squared to the numerator's power minus the denominator's power. Right? So if I had x cubed over x squared, it'd be x to the 3 minus 2, it'd be x, right? So properties, so like bases. So that's there. And then let's just do the same thing on here, and then we'll clear it off. So I've got x cubed divided by x. So I've got x to the, so here I'll do it. I've got x to the power of numerator minus the denominator. I'm doing it with x's not to insult your intelligence, but just to show you that we're dividing like bases. And then you've got your 9 minus your x squared to the -1/2 minus the denominator's power of -1/2. And that's all there. Okay, so let's just keep going. All it's going to do is take 4 times practice of difficult ones, and you'll have this down. It'll be fine. So then let's just move up. So we obviously, we have our x, we have our 9 minus x squared to the -1/2 power. Now, we have our 2. Now, help me out. So I have 1/2 minus a -1/2. So 1/2 minus a negative, that becomes positive. So 1/2 plus 1/2 becomes 1. So that means I've got a 9 minus x squared to the power of 1. Then I'm moving on to my next term, separated by a plus or minus there. I shouldn't do that. Separated by the minus. So x to the power of 3 minus 1, so that's x squared. And then I've got 9 minus x squared to the power of -1/2 minus a negative. So negative 1/2 plus 1/2. Negative 1/2 plus 1/2 is power 0. Did I do that right? Is it right? Negative 1/2 plus 1/2. Okay, that's good. Okay, so then let's keep going. So we've got x 9 minus x squared to the negative 1/2 power. Now, now you can grab it out of the function because it's a power 1. So that's just that's just 9 minus x squared in parentheses. That's all that is. So that becomes 18 minus 2x squared minus x squared to the power of something, a base to the power of 0. Anything to the power of 0 is 1. Let's keep going. So now you've got x times 9 minus x squared, negative 1/2 power. I've got 18 minus 2x squared minus another x squared. So I have 18 minus 3x squared. Almost there. What I am going to require now is GCFs, and in your final answer, make the powers positive. So that means everything that is in the numerator. So let's see, I've got an x and an 18 minus 3x squared. Like I would do this in one step, or we would have cut a lot of steps out, but I'm going to write it out. X times 18 minus 3x squared. Those are all positive powers. Power 1, power 1. The negative power goes down here. So that's a 9 minus x squared. You can write it as 1/2, or you can write square root. It doesn't bother me. Now we're done cleaning it out. Let's just put a square root there. And obviously, you and I would distribute the x if it were the final answer. But I can tell you're all getting tired of writing. So we're just going to stop there because I don't want it to write anymore. So you're going to do one exactly like this. And I'm going to give you, and then anyone watching the video will just stop it and try and do it. So I'm going to give you a practice example, and I'll leave this up on the screen while we're doing it. So the practice example will be x squared divided by the square root of x to the 9th plus 9. Before I let you do it, before I even stop the video, you're going to see why I actually, as a student, never used the quotient rule. Now you know the chain rule, you can do everything as a product. And I'm not going to write it, but I'm going to say it. So see if you can hear it. That can be written as x squared times x to the 9th plus 9 to the negative 1/2 power. Then you have a product and a product chain, and it actually, in my opinion, and everyone's got an opinion, is neater than the quotient rule. So, all right, so I'm going to stop sharing, and you get up for dinner, get ready.